All right, Trig Worksheet 2. Here is your recap. At this point, it should be coming together, and you will see on each side I have SOHCAHTOA to the left, because when the problems are easy, you let SOHCAHTOA do the work. When the problems get a little bit more challenging, you let SOHCAHTOA do the work. So the only thing I'm going to go over here on number 1 is just a reminder. At this point, when we set up a trig function to solve for a missing side in the variables on the bottom, I hope we can see this process that plays out. In number 1 here, I would multiply both sides by c. That would get rid of the c, and then I would divide both sides by tangent of 39. So 37 divided by tangent of 39 gives me 45.7. But the more we do this, the more we're going to realize when that denominator is the variable, that we're going to see those two switch right there. So when d, as in the case here, is in the denominator, this problem will be solved 37 divided by sine of 39. So hopefully at this point you have noticed that pattern, so that every time you have the variable on the bottom, you're able to just swap it out with the trig function. So case in point, in number 2, I would solve this problem, since the variable is on the numerator, just by multiplying both sides by 79. 79 times tangent of 31, final answer. For m, because m is on the bottom, I'm not going to multiply by 79. This problem, I'm just going to swap out cosine of 31 with m. Final answer, 79 divided by cosine of 31, 92.2 is your final answer. And just letting SOHCAHTOA do the work with the opposite, adjacent, and hypotenuse, putting it in that equation, and then being comfortable with x being on top or on bottom, being able to solve, will get you through these first 6. The biggest thing that could come up here is, how do we go backwards and solve for a missing angle? So that it's still SOHCAHTOA doing the work, but this, when you're solving for a missing angle, that is when you're going to use the inverse. So you set it up. In this case, if I'm looking for angle A, from the vantage point of angle A there, I have the adjacent and the hypotenuse. So basically, the cosine of A is equal to 6 over 23. So how do I solve for that? To solve for A, you undo, solving for A, you undo the cosine by doing the cosine inverse. You do 6 divided by 23, and that's how we come up with that value right there. So to solve for an angle, you use sine inverse, cosine inverse, tangent inverse. Which one do you use? Just based off the sides that you are given. That leads us all the way to the end here, solving for the missing parts of the triangle. I will say this: if you are given one angle, 180 minus 90 minus 33, that's how we're going to come up with that. You don't want to overcomplicate that. Same idea here in number 11. We've got 90, 20. Don't overcomplicate that. That has to be 70 right there. If they give you 2 out of 3 legs, 2 out of 3 sides instead of 2 out of 3 angles, we would use Pythagorean theorem. Again, no need to kind of overcomplicate it. Go back to, when did we learn it in the year? That's probably the best approach. So 3 angles in a triangle add up to 180. Let's use that. If I have 2 out of 3 sides in a right triangle, use Pythagorean theorem. Instead of, like for instance in number 10, trying to get a missing side length for PQ or QR, then going back and doing inverse trig, it's going to be easiest just to do 180 minus 90 minus 33 to get angle P. Okay, and again, in each one of these, we take a look, we set up the trig function, we solve. When x is on top, we multiply by the denominator. When x is on the bottom, we just take the side length and divide by the trig function. So at this point, it should all be coming together here as we finish and wrap up trig worksheet number 2.